For decades, we've been on this quest to teach computers what might be our most human skill of all, language. And it's a story that's filled with incredible ambition, some pretty crushing failures, and a revolution that, well, it changed everything. So let's dive into how it all happened. I mean, think about it. When you ask your phone for the weather, or your email somehow knows what's spam and what isn't, it kind of feels like magic, right? But it's not. It's actually the result of this long, fascinating journey in the world of artificial intelligence. At the very heart of all this magic is something called natural language processing, or just NLP for short. It's the science, and really the art, of teaching machines how to work with our messy, super nuanced, and kind of beautiful human languages. All right, so where did this all begin? Well, the first attempt was logical, but oh man, was it difficult. We basically tried to teach computers language the same way you might have learned it in school, by giving them a giant, and I mean giant, book of rules. This first phase, they call it the symbolic era, and it started off with a bang. In 1954, this thing called the Georgetown experiment managed to automatically translate some Russian sentences, and people were ecstatic. A little later, a chatbot named Eliza could mimic a therapist so well it was honestly a little spooky. But that optimism, it didn't last. By 1966, a famous report came out that basically said progress had totally stalled. Why? Because language is just too messy, too ambiguous for handwritten rules. The approach was just too brittle, and it led to huge cuts in research funding.
And you have to love the confidence they had back then. After translating just 60, that's 60 sentences, the researchers made this unbelievably bold prediction. They really thought they'd pretty much cracked the entire code.
Yeah, they weren't even close. Turns out, language is just this tangled web of ambiguity, exceptions, and context that a simple list of rules could never, ever hope to capture. The problem was just way more complex than anybody had realized at first.
And this comparison just illustrates the two philosophies perfectly. The old symbolic way was like trying to write a grammar book that could account for every single thing a person might say. It's impossible. The new statistical approach, which we're about to get to, was more like giving a computer the keys to a massive library and just telling it, go read, figure out the patterns yourself.
So after that whole rule-based approach kind of crashed and burned, leading to what people call an AI winter, a completely new idea started to pop up in the late 80s and 90s. And this wasn't just a small step forward. This was a genuine revolution that changed the entire field. So what made this revolution possible? Well, it was kind of a perfect storm. First, the internet. All of a sudden, we had this unimaginably huge ocean of text data for computers to learn from. Second, Moore's law meant that computers were finally powerful enough to actually swim in that ocean. And this led to some early breakthroughs, like when IBM used a bunch of multilingual government documents to train their first translation systems. And this is the absolute key point. The whole mindset just flipped. We stopped trying to be the strict teacher writing rules on a blackboard. Instead, we became librarians, just gathering up huge amounts of text and letting the machine learning algorithms find the patterns all on their own. And that brings us right up to the modern era. Just when it seemed like these statistical methods were the final answer, another huge leap forward came along and supercharged everything. And that was deep learning and neural networks. The big change here was essentially cutting out the middleman. You see, with the older statistical methods, humans still had to do a ton of work up front, telling the machine what parts of the text were important to pay attention to. Deep learning models, which are kind of inspired by the structure of our own brains, could just figure that out for themselves, leading to these massive jumps in performance across the board. This was the real game changer. Computers went from just counting words to actually learning the relationships between them. They started to get that king is to queen in the same way that man is to woman. They weren't just processing text anymore. They were starting to capture the meaning embedded inside of it. Okay, so we've gone through all this history. But why does it matter? Well, because this technology, built on decades and decades of trial and error, is now completely woven into our daily lives. NLP is constantly helping you make sense of the world. It's what summarizes a long news article for you, what tells you if the reviews for a product are generally positive or negative, what translates a foreign website in the blink of an eye, and, of course, what keeps your inbox from being a total disaster. It's also there helping you create things. Every time your word processor fixes a typo or your phone suggests the exact next word you were about to type, yep, that's NLP.
It's even the engine behind those amazing text-to-speech and text-to-image tools that are everywhere now.
And maybe the most obvious way we see it is in how we interact with technology. Every single time you talk to a voice assistant or ask a search engine a question just using normal language, or get help from a customer service chatbot, you're using the direct descendants of all those early experiments.
So we've come an incredibly long way from trying to write down grammar rules in a notebook. But this quest, it is not over, not by a long shot. So what's next on the horizon?
The next great frontier, the next mountain to climb, is moving beyond just processing language to something more like true understanding, more like cognition. The goal is for these machines not just to predict the next word in a sentence, but to actually reason, to comprehend deep context, and to really truly grasp the meaning behind our words. And that leaves us with a final and pretty deep question to chew on. As these systems continue to get better and better at mastering our most defining skill, what does that mean for us? As they master language, what will it truly mean to be human?